Alright, so remember when you're given rational functions or things that are kind of like rational functions, like this one is, and you have to find the limit as x approaches infinity or negative infinity, it's important to look for where the dominant term is located. Just to review all three situations, if your dominant term, your greatest powered term, is in the top, then your limit as x gets big is going to not exist because you're dividing infinity by a small number. You're not going to be able to quantify that. If your dominant term is in the bottom, then the limit's going to approach 0 because you're dividing some finite thing by infinity. That's going to chop it into pieces that are basically size 0. And if there's a tie, if you have the dominant term in both the top and the bottom, you make a ratio of the coefficients of the dominant terms. And it turns out that's what we have going on here. It appears as though we have an x to the 6th in the top and an x to the 3rd in the bottom. But in reality, if you take the square root of 16x to the 6th, and you should because the dominant term is sitting inside a square root, you are going to end up with 4 for the number portion and x cubed for the exponent portion. So your dominant term in the top, once you take into account the square root, is really 4x cubed, and on the bottom is 2x cubed. We have a tie for the dominant term in both the top and the bottom, so we make a ratio out of their coefficients, which gives us 2 for our solution.